Hello, welcome back to the Unknown IITians channel. And we are revising computational thinking week 2 here. And today we'll be doing some operations on iterations. So, in the last video, I introduced to you what iteration is. And today we'll be revising it and understanding it further and doing operations on it. And also, I'll be introducing you to pseudocodes, which is basically the most important part of the computational thinking because you'll be working on pseudocodes for the rest of the term. So make sure your basics are strong. So I'll introduce you to it, and also the video is going to be a little long because we'll be doing a lot of questions today, and doing questions is literally the most important part. So make sure even after the video you go through a lot of questions to make your topic, make your base stronger. So let's get started. So what is iteration? Going through a sequence of objects and performing the same operation on each object. So as you see here, this flowchart says there's a start, then there's a loop, then there's a condition, and as long as the condition is met, as long as this condition is true, the loop keeps repeating. So this loop is the iteration, and it's going to keep repeating on multiple objects as long as this condition holds true. So that is what iteration is. And now we look through a few operations. So the first one is conditional termination or termination in iteration, which refers to a process where an iterative loop continues to execute until a specific condition is met. So here a loop will be continued until your given condition is met. Suppose you have the marks data set, and your condition is you need any one male student from the entire data set. So like suppose you go through the data set and the first card is a female, the second card is also a female, the third card is now a male. So your iteration stops right here. It's not gonna go through the rest of the cards. It terminates right here. So if we were to differentiate between conditional and normal termination, then as I said, in conditional termination, your code will end, the process, the loop will end as soon as your condition is met. For example, in our example, the condition was the student being a male. So the first card is a female, second card is a female, third card is a male. It terminates here. But in case of normal termination, it's gonna go through each and every data, even though this condition is met, because we haven't specified we need to terminate at this point. So if we need only one male, and we don't need to, in that case we don't need to go through the rest of the data, right? So in this case we're going to use conditional termination. So conditional termination is dynamic and depends on the condition, allowing early termination. So the extra steps are removed. Normal termination is static and executes a predetermined number of iterations without interruption. So of course a normal termination, it's gonna terminate only when your data is over. Only there's no more data left to be checked. Now we're gonna look at some questions related to conditional termination. And here it says another card and not of found. So what does not of found mean? It checks is found false here. Every time it says not of something, that means it's checking whether the condition is false. So, and there's a and operator in between. So if there's a and operator used, then both the statements should be true for this entire thing to be true. So as long as both these conditions are met, this will move forward. So here we are checking for a particular card. So it could be any card. So this is a condition. So the loop will continue to execute as long as this card is not found. This card is not been, we haven't got this card, because as soon as we get this card, we go to yes here, and found becomes true. And as soon as found becomes true, this condition doesn't satisfy. And if this condition doesn't satisfy, there's an and operator here. So if either of the condition fails to satisfy, then the loop stops. So for for this condition, so this condition has to be true for the loop to stop. So let's see the first question here. If the variable found stores the value true, what will be the outcome of the operation not of found? So as I told you, not of found is checking is found false, and not of something that is true is going to be false. So the answer for this is false. Another question. Consider the first decision block used in the above flowchart. After a certain number of steps in the iteration, the flow transfers to no branch. Which of the following situations are possible at this stage of the program's execution? So we have to check when it's going to stop. So when it's going to go to the no branch, this no branch. So it goes to the no branch if either of these two becomes false. Even if one of this is false, it's going to stop. So it stops only when there's no more card left or found becomes true. If found is true, this condition doesn't meet and it's gonna stop. So the found variable stores the value true. If found is true, it's obviously gonna stop as I showed you. The found variable stores the value false and some cards have not been read. So it wouldn't stop in that case because we either need the cards to be over or found to be true. So not this and not this either. So the third one, the variable found stores a value false and all the cards have been read. So if all the cards are read, then obviously there's no more card to iterate the thing over. So it's gonna stop in that case. The found variable stores a value true. So it's correct as long as the found, as soon as the found becomes true, then it's gonna stop. So that's it for this. Okay, there's another one. At the end of the execution, the variable found stores the value true. How many times was it updated? And as soon as found becomes true, this loop stops, right? As soon as it becomes true, it goes here, so it stops. So it only goes through the it only goes through the loop once when the found is updated to be true. So this is gonna be the correct option. Consider the following flowchart. So this flowchart pretty much looks the same. The only difference is there's another variable here, which is a count variable, and the count is incremented when the correct card is met. So you might not understand what count is equals to count plus 1 means because mathematically it's incorrect, but when we're doing pseudocode or any other type of code, this is the original value of count, which is 0 here in this case, and this is the new or updated value. So here the value is going to be incremented or updated when the correct card is met. So in our loop, as I told you before, this is going to stop when the correct card is met, right? So it's only the value of count is only going to be 1. And the question is, if there are 10 cards that satisfy the condition for correct card, what will be the value of count at the end of the execution? We don't care about whether there are 10 cards or whether there are 30 cards or 50 cards because it's gonna terminate as soon as the first card, as soon as the condition is met. So as soon as the first card is the correct card. So as soon as one card will be correct, this will go to yes and the loop will stop. So the count is incremented only once here. So the value of count is going to be 1. So the next topic is local operation and max in single iteration. So iteration is a broader concept focusing on repeating operations over data, and filter is specialized operation within iteration that selects element based on a condition. So what does filter do? It selects element based on a condition. So there's a condition and it's gonna pick out the elements for this condition. So for a last example, we just needed one male student, but let's say we need all the male students from the entire class. So here our filter is the male students, right? So our code will be something like if gender is equals to male, then increment count. So this would be a filter here. So let's see the difference between with filter and without filter. With filter adds a condition check for step for each iteration, and without filter no condition check, simpler execution. So in our example, the condition check was the gender condition, and the output contains only the element meeting the condition. So the output in our case was the count of the number of male students, whereas without filter we are just counting the total number of students. Efficiency, more efficient for irrelevant elements, and without filter may process unnecessary elements. Use case, when you need specific elements from input. So when you only need to count or sum a part of the entire group, not everyone from the group. And we use without filter when you need to go through every element and check every element. Suppose we wish to find the shortest sentence in the paragraph words dataset. We decide to use two variables, min and count. Keep track of the length of the shortest sentence. So the shortest sentence is for min seen so far, and the length of the current sentence, which is the count, respectively. Which of the following is valid in initialization for min? So for min, we have to find the shortest sentence, right? So whenever we have to find the shortest or the least or the smallest of something, we choose a larger number. Why? Because we always need min to be greater than whatever the first input is. So let's say the first length of the first sentence is 10 words. So it's going to be less than 10,000, right? Obviously. So this 10 would be updated to min in the next step. So let's say the next sentence is like 6 words. So 6 is less than 10. So it's going to be, min is going to be 10, min is going to be 6 again. So that is how we're going to find the shortest one. So obviously we're going to start with the bigger number. And in case of maximum or the largest of something, we start with 0 or a smaller number, because the maximum is supposed to be less than whatever the value is for the value to be updated here. So that is the case. For maximum we go for a smaller number, and for finding minimum we go for a larger number. So let's see the question here. Arrange all the cards in single pile called pile 1. Maintain a variable max and initialize it to 0. Read the top card. If letter count is less than max, then set max equal to letter count. So the problem is the letter count should be greater than max, because we have to find the largest letter count here. So it should be greater than max. So this should be like this here. Set max equal to letter count. Move the current card to pile called pile 2 and repeat from step 3. So we have to see which step is wrong here. So obviously it's step 4 because the sign is inverted here. Next question. Consider the following variables and their corresponding value. SV stores the total revenue generated by SV stores. Similar for SG revenue for Sun General. BB is revenue for Big Bazaar. SV count is the total number of bills generated by SV stores. SG count is similarly the bills of Sun General, and BV count is bills of Big Bazaar. So, which of the following expressions gives the average revenue generated by all shops put together? So, for finding average, we have to find the total revenue by total bills. So, the total revenue will be revenue of all the three shops combined, and the total bills, as count is a bills, so it will be all the three bills combined. So, this will be the answer. The variable average stores the average revenue generated by all the shops. Which of the following expression checks if the average revenue generated by SV stores is more than the average revenue generated by all shops. So for average revenue of SV stores, we have to find the revenue of SV, which is SV itself, by SV count. So it should be more than the total average. So this is the answer. Next question. Let SV, SG and BB average represent the average revenue by all these three shops. How many pairwise comparison among the three variables would be needed to find a shop with maximum average? So to find the maximum average, suppose we compare two of them first, suppose these two, and suppose this has the bigger value. Now we have to compare it with the third one. So whichever one's the bigger gives us the answer. So we just need two comparisons for this. So the answer is 2. Next, max in single iteration and max in two iteration. So we saw how to find the max in single iteration. So I told you for finding maximum, we initialize max as 0 at the start, and whatever is less than max gets updated to max in the next step. So this is for single iteration. Now for two iterations, suppose we need to filter out the data before finding the maximum or minimum or whatever. So to filter out, suppose in the scores dataset, we only need to find the maximum total marks among the females, among the girls of the class. So in the first step, we are filtering out the data, and in the second iteration, we are finding the max. So this thing requires a pre-processing. The pre-processing could be filtering or transforming. The problem involves additional condition before identifying the max. So the additional condition could be adding a filter or anything. So that is about two iterations. Let max marks be a variable that keeps track of the maximum total marks in the scores dataset. Let max card be a variable that keeps a track of the index of the card which have the maximum marks. We write a procedure similar to the one given in the lecture to determine the maximum total marks and the index of the card corresponding to it. If max marks is updated n times during the execution, how many times will the variable max card is updated? So max marks is updated n times, right? And also no two cards have the same total marks. So in that case, the max card or the index of the data will also be upgraded n times because every card has a different mark. Suppose one or two card had different marks, then that would be a different case. If one card had different marks, it would be n minus 1. Since that card will not be counted twice. So, but since we do not have same total marks here, it's gonna be n. Next question: if there are n cards in the pile, assume the pile is arranged in ascending order of marks. So the total marks given in any card is always less than the total marks in the card immediately below it. So basically the cards are arranged in ascending order according to the marks, and no two cards has same total marks. How many times will the variable max card be updated? So this question is the same as the previous one. Again, since there are no cards with the same marks, so of course it's going to be updated n times. So this procedure is from the paragraph words dataset. Arrange all the cards in pile called pile 1. Maintain two variables, count and prev, and initialize them to 0 and none respectively. So we have count as 0 and prev as none. Read and move card at a time from pile 1 to pile 2. If a word is equal to was and prev is equal to it, increment count, store word in prev. So let's say what we're doing here is, let's say the first word is it. So in the first case, prev is stored as none. So we put an increment count here because the conditions are not met. But then in step 5, it says store word in prev. So this word would be stored in prev. So in our next step, prev is changed to it. Prev is changed to it, and then we move on to the second word. Suppose it's was. So in this case, even this condition is met and also this condition is met. So we'll increment count in this case. So every time there's a sequence which says it was, So every time there's this sequence, we are incrementing count. So it computes a number of times the phrase it was occurs in the paragraph. So this will be the answer. Flowchart of max marks. So here max is initialized as 0 because I told you, right, whenever we have to find the maximum, we start with the smaller number. We initialize it as a smaller number, and then we're checking if there are more cards in pile 1. Pick card from pile 1, move to pile 2, and then we're checking if card X max is greater than maximum marks. So in this case, suppose the first card is like 56 marks, which is obviously greater than 0. So it will move to yes, and then max will automatically be stored as 56. And then suppose in the next case we got someone has scored 87. So 87 is greater than 56. So again it will go to the yes direction, and then the max marks will be stored at as 87. Then suppose the next card says 63, then 63 is not greater than 87, right? So it will go to the no direction, this direction, and then we have to check if there are more cards here. So in after this step, the max would still be 87. So this is how the iteration would continue. These are the steps for iteration, and then at the end the max will store the highest marks. If 87 is the highest, then it will obviously store 87. If we have a mark greater than 87, then that value will be updated in as max, and it will be stored. So here we have a similar kind of flowchart. The only difference is max card ID is also stored here, and then when we are updating max as the card, we also update the card ID here. And also there's another thing. If suppose the highest marks is 87, and there are two students who got 87, let's say roll number something, roll number 12 has also 87, and roll number 32 also has 87. So in that case we cannot avoid this second person, right? We still have to add the ID of this person. So if the maximum marks is the same, then this ID is also appended because we cannot ignore it. So that is the case here. Consider the following flowchart discussed in the lecture. Now we'll do some questions based on this flowchart. If there are n cards in the dataset, how many times is the first decision block visited? So the first decision block as in this block. So it says there are n cards. So for every card, it's gonna go this side or either this side or this side. So for every card, it's gonna visit this block once, right? So n times plus 1 time because it's gonna visit again for this no block when this goes to no. So one more time, so one extra time would be visited. So the answer is n plus 1. Second question, a programmer changes the second decision so that it's question says a programmer changes the second decision operation so that it reads as follows: card x max is less than max. So basically this sign here is changed. All the other blocks are left unchanged. If we go by this flowchart, what does the value max store at the end of the execution? So here we have max as 0, right? And it says something should be less than 0. But in our case, nothing can be less than 0 because no one can store less than 0 marks, right? Unless there's negative marking, which is not mentioned here. So no one would store less than 0. So the value is either going to be 0 or something greater than 0, which is not possible. So every time it's going to go to the false side. Every time it's going to go to this no side. So this will never visit this block, and the value will always store 0 because the value of max will never be updated. So max will be 0 even if all the cards are checked. So it stores a value of 0. Next, continuing the previous question, how many times will the last block in the flowchart be visited? So they're asking how many times will this block be visited, this block, given that this thing is changed, because it said continuing the previous question. So as I told you, it wouldn't even visit once because it's going to the false side every time. So it would be 0. Next, the programmer realizes his mistake and reverts the original flowchart. But now, for some weird reason, he decided to change the second block to read as max is equals to 98. What would be the variable max at the end of the execution? So now it says that the programmer reverted this back. So this is now normal, but he changed max is equals to 98. So what will be the value of max at the end of the execution? So let's say in our data nobody has scored greater than 98. So max would always, so it would go to false every time again, and then max will store 98 at the end. But in case someone has scored something like 99 or 100, then in that case it will go to yes here, and the value of max will be updated to these values. So either it will store maximum maths marks provided that there is at least one student who has stored greater than or equal to 98. Of course, if someone has stored equal to 98, it wouldn't be upgraded, but of course it will remain 98 even at the end. So yeah, if no student has scored more than 98, max will store the value 98. So as I told you, if everyone has less than 98 marks, then it will be 98 even at the end. Now, introduction to pseudocodes. So, what are pseudocodes? These are basically very similar to the coding languages which we use for programming, but not actually a coding language. But it will help you form the basics for a lot of coding language when you actually start learning Python or anything else. So, yeah. So, we have pseudocode in our course now. So we have seen flowchart, we have seen steps so far. Now moving on to pseudocode. See, the start is same. This count is initiated as 0. This is the same. And instead of this decision box, we have this while loop here. So this is called the while loop. And inside the while loop, we have these steps for iteration. See, these and these are the same. These are the iteration steps. So pick x from pile 1, move x to pile 2, increment count. This is the same as you have seen in the flowchart. And this statement here, while pile 1 has more cards, so this while loop will not be exited as long as this statement holds true. So here this is the part where the while loop is exited. This is the part where it starts. So we'll remain inside this loop as long as this statement holds true. So if as long as there's more card in pile 1, we will stay inside the while loop and this iteration steps will be continued. As simple as that. And usually we do not use the start and end thing in the pseudocode to make it shorter because we know when it's gonna start and when it's gonna end. So yeah. So this question says, is the following a representation of a pseudocode? So clearly a pseudocode looks like this and these are just steps written. So these are just steps. So this would be no. In case we had to change this to pseudocode, then the first thing we would write is initiate count as 0. So count is equals to 0. Then for this we have to enter the while loop and the condition would be more cards in pile 1. This would be these brackets. So the bracket matters. The loop starts when the curly bracket starts, and if we use round brackets, then it's just the condition. Then we would write these steps, these iteration steps here. These steps would be written here. Pick card from pile 1, move card to pile 2, then count is equals to count plus 1. And after all these steps are done, this while loop will be exited. So we'll use a bracket here and then this thing will end. So this is how we change steps to pseudocode. Then next question. If there are n cards in a dataset, what will be the variable count stored at the end of the execution? So count is initiated at 0. Then we enter the while loop and the condition is pile 1 having more cards. Pick x from pile 1, move x to pile 2. Increment count here is written twice. So since count is incremented twice, then n will be doubled. If it was only written once, then we would get the value as n. But since it's twice, then we get 2n. What will happen when the above code is executed? So again we have another code. Count is initiated at 0. While pile 1 has more cards, pick x from pile 1, move x to the bottom of pile 1. So the card again is moved to the same pile. It's not changed. So this condition will never become false. This condition will always be true. And then we will never exit the while loop. So the code will never actually stop. So the code will never terminate and keep running forever since the cards repeat again and again. So we have a pseudocode for finding the sum of boys and girls maths marks. So I'll see you how it relates to the pseudocode, how the pseudocode relates to the flowchart. So the first step is initializing this as 0, and here as well the girl sum would be initialized to 0. So we enter the while loop then, and this is like for the while loop. Then pick one, pile 1 has more cards, pick x from pile 1, move x to pile 2, and there's another loop here. This is the if loop and this is the else loop. So see how in this we use a filter to check if the gender of the card is a male, and if this is a male it's going to yes and the boy sum is added. If this is not a male, if this is false, then the girl sum is being added. So even in case of this pseudocode, if this condition is true, then we go here and the boy sum is added. And if this condition is false, this is when the condition is false, the girl sum is added. So this is how it relates to the pseudocode, and we have a lot of loops here. So this is for the while loop, and this is for the if loop, and again this here is for the else loop. So that is how it's written as pseudocode. We use multiple loops here. Another example, finding the card with maximum marks. So the max m is initiated as 0 and max card is initiated at -1. And why do we use -1 is because some card can have a serial number of 0. So we cannot compare 0 with 0, right? So we use -1 here because nothing can be less than -1 in our case. Then we have the while loop. So this decision box is used instead of while loop. So it says pick x from pile 1, move x to pile 2. And then we have the if loop again. So you see this filter here. This if loop is used instead of this filter. So it says if x max is greater than maximum marks. So we are checking for maximum marks here. So as long as this condition is true, we enter in this part. So if we get a card with marks greater than the maximum marks, then the maximum marks will be upgraded as the marks of the given card. And then the ID will also be upgraded here. So at the end, max m will store the maximum maths marks, and max card will store the ID for this card. So this is the case of the pseudocode. What can you say about the two lines of the pseudocode given below? So first is initialize at 0 and second is also first. So both of them be 0. So we have to say which statement is correct. Statement 1 is an assignment statement and statement 2 tests for equality between the two variables. So the difference here is this single equal to is used for assignment, and if we use double equal to, it's used to check equality. So here we have used single equal to, right? So this is an assignment statement, and here also we have used single equal to. So this is also an assignment statement. So both are assignment statements. In the following pseudocode to calculate the sum of physics marks of all the students may have some incorrect statements. Identify the erroneous statements. So we have to check which statement is wrong here. So it says sum is equals to 0. We are not checking for equality. We are not stating the fact that the sum will always be equal to 0, but we have to assign sum is equal to 0 to initialize it. So this would be wrong here. So line 1. While pile 1 has more cards, pick x from pile 1, move x to pile 2. Sum is equals to sum plus x maths. So what's wrong here is it says physics in the question, but it's adding maths marks here. So this would be wrong. So this is line number 5. Next, consider the following line in a pseudocode to calculate the sum of chemistry marks of all students. So sum is equals to sum plus chemistry. Which of the following are equivalent to the statement above? And the first option is sum is equals to x chemistry plus sum. So here, whether you're doing something like 5 plus 4 or 4 plus 5, both of these are equal, right? So this is the same case here. So both of these would be equal. Next, sum double equal to sum plus x chemistry. So this is for checking equality, and this is not an assignment statement. So mathematically this will be wrong because both these values are same, so this would be cancelled. And x chemistry would be like 1, so this is not correct. X chemistry is equal to sum plus x chemistry. So the problem here is this sum is a variable, but this x chemistry is not a variable. This is a constant, so this cannot be changed. So these two statements are wrong because the x chemistry would say remain same for any particular card, but the sum would be updated every time. Sum is a variable. Next, a programmer wishes to determine the minimum marks chemistry. Help her complete the following pseudocode. So we have to update the statement 1 and statement 2 here. So let's see. We have to find the minimum marks in chemistry. So for minimum, we have to assign a large value. So the statement 1 would be minimum is equal to large value. So this minimum chemistry is 100. 100 is a large value. So this statement would be correct. Then pick a card from pile 1, move x to pile 2. Then we have to add another if statement here, which is the filter basically. So to find the minimum, we have to find something less than the minimum because we have to find the least value every time, right? So this would be x chemistry less than minimum. Then we are doing some more questions here. Says the following procedure counts the number of students from Bengaluru whose total marks are less than the average total marks from the scores dataset and stores it in variable A. So variable A is the count of students whose total marks is less than the average. Let ABGT be the average total marks. The programmer may have made some mistakes in one or more steps, and we have to identify the mistakes. Step 1, arrange all the cards in pile 1, initialize A to 0. Pile 1 is empty, then stop the iteration. Read the top card from pile 1. if X city is equals to Bengaluru, because it said Bengaluru in the question, and if X total is greater than average T. So this should be less than average T here, because we have to find the total less than average, not the total greater than average. Then add 1 to A. So the step 5 would be wrong, so this option would be correct. Then move the current card to another pile called pile 2 and repeat from step 2. Step 2 is initialize variable A to 0. This shouldn't be the variable A shouldn't be reset every time we do the iteration, because we have to find the total number of people with less than average. So if it resets to 0 every time, then we would end with 0 or 1 at the end. We wouldn't find the total number of people. So this should be step 3, not step 2. So step 5 and step 6 should be corrected. Next question, at the end of the execution of the given procedure on the scores dataset, what will A and B represent? Arrange all the cards in pile 1, maintain variables A and B, and initialize A to 101 and B to 0. If pile 1 is empty, then stop the iteration. Read the top card from pile 1. If A is greater than chemistry marks, then store chemistry marks in A. And if B is less than mathematics marks, then store mathematics marks in B. So we have to see the least number of marks. We have to see the lowest chemistry marks here, because it says A if chemistry marks is less than A. So we are finding the least chemistry marks here, because A is a large number and we have to find the lowest chemistry marks every time we go through the iteration. And B is a small value, and we have to find something larger than B. So every time we iterate through it, we get a larger value. So B is for finding the highest math marks. So A is the lowest of chemistry and B is the highest of math. Next, at the end of the execution, given in the procedure words data set, what will A represent? So arrange only cards in pile 1, maintain variables A and B, initialize A to 1000, B to 0. If pile 1 is empty, then stop the iteration. Read the top card from pile 1, add letter count to variable B. So letter count is the number of letters in a word, in a particular word. If word does not end with a full stop, then execute step 9. And if word ends with a full stop, so we go to step 7 only if the word is the last word of the sentence, because only then it will end with a full stop, right? So if it's the last word of the sentence and if B is less than A, then store B in A. So let's say the B is basically the sum of all letter count in a particular sentence. So that is B, and if B is less than A, then it is stored in A. So every time we are finding a smaller value, right? So we have to find the length of shortest sentence based on the count of the letter. So let's see the options. Length of the shortest sentence based on number of words, not words, because we are looking for letter count here. Length of the longest sentence, no, not the longest. Then this is also wrong. The length of the shortest sentence based on number of letters. This is correct because we are looking at the letter count here. So that's it for this week. So make sure you practice as many pseudocodes as possible, and I hope you understood the concept here. And the more you practice, the better you'll get at it, and the more you'll understand. So practice as much as possible, and thank you for watching.